Hello everyone, my name is Dima Kagan, and I am presenting our work about the use of social networks in order to search for experts. Our team is from Ben Gurion and Bar Ilan universities, from Israel, and our main specialization in the social network area, so I think it's obvious why we choose this approach. The challenge this year is to find experts from different kind of text, like job descriptions, conference programs, and patent papers. Our approach is to social networks and wisdom of crowds. We believe that crowd wisdom and social networks today are pretty much the same, because the social network gives us the ability to learn what people think, believe, and even who they are considered an expert. In social networks, people can express themselves by giving likes, sharing something, commenting or posting. And in academic network, by following someone, we basically saying that we are consider him as an expert. In order to achieve this goal, we choose to use supervised learning. And it's possible because today social networks are much more than just a communication mean. You can talk to someone, but you also can collect a lot of information about locations, about hobbies, interests, political views, about almost everything. And by using techniques like machine learning, it's possible to find a lot of more about other people. I will show now several examples of such researchers, like Krebs. He used the social network analysis in order to map the 9/11 terrorist cell. He mapped the full neighborhood of the terrorists, their associates, and by using a centrality measure, he found the four leaders of the terrorist attack. Another example is from our research about identifying fake profiles in social networks. Most of the fake profiles send a lot of random friend requests, so they have a lot of small communities of friends. A real person will have several big ones of people from work, from the neighborhood, from his job. So it's possible by machine learning to identify who is a real person or who is not. And the last example, and I think it's the most relevant to our case, it's part of from where we took this idea, is identifying the managers inside of social network over social networks. We called Facebook for organization and built a social network. And by using a centrality, we were able to find the managers inside the organization. Managers are are pretty much similar to an expert. They are the most central people inside their own social network. So in our case, we consider the academic papers as a directed social network. When you see someone, it's like you're following him, and when someone sees you, it's like he follows you, like in Twitter. So we think that when someone is cited in many papers, it's probably an expert, because other people base their own work on his. So they consider his work as the important one, and they believe his results are true and conclusions. So I now will describe our architecture. We have a two-part pre-process. The first one is pre-processing. We had the Mendeley dataset. In addition, we took data from Microsoft Academic Search, which is a search engine for academic papers, authors, journals, conferences, and other academic information, and we called Academia EDU, which is a social network for academic purposes that gives researchers the ability to communicate with their colleagues, follow their work, papers, and other stuff. We built it from these three data sources, social network, and put it inside our database. Afterwards, when a user performs a search, we took the text and sent it to Yahoo API in order to get the topic of the text, and search inside the social network the most connected node for this topic. In the beginning, we had only the Mendeley dataset, and the result was not as good as we expected. We built the social network, and we got this graph. It has a lot of small clicks, so measures like centrality, PageRank would not be very efficient. In order to improve our results, we crawled Academia, as I mentioned before. The result was much better. We had one big graph and several smaller ones. So graph features much more efficient in this way. The second step was to use feature extraction. And we used two types of feature, graph features like centrality, page rank, betweenness, and closeness. The idea is to find the most central and most important nodes of the graph, which are probably the experts. And with content features. The first one is journal rank. It's based on rate rank. The idea is to give a higher score to a paper that was published in more important and prestigious journal, like, for example, Science. And the second feature is number of readers. Again, the same idea. We think that the papers that was read by many people is more important than other papers. And the final step is to use machine learning in order to find really who is an expert with the C4.5 decision tree. The training set, we classified it manually by ourselves, several hundreds of examples. Originally, I prepared a video, but I think I will do a live demonstration. It will be a little bit more interesting. And for the first example, I will take the HCIR conference. I think it would be appropriate because we are here. Before that, I will explain a little bit about our UI. We have a big text area, search button. I'm feeling lucky, like in Google, and several checkboxes for filtering. So let's search. So we got several keywords. As I mentioned before, we're using the Yahoo API. Yahoo giving us a service of term extraction, and it's one of I think is the biggest problem in this area, to find the text topic. Because text can have several topics, and Yahoo will do it much better than we are. So Yahoo returns us several possible topics. We have here information retrieval, human-computer interaction. I think it's pretty good ones. And for example, I will choose the information retrieval. Now, because we cannot have all the topics inside our database, we use the Levenshtein distance in order to find the closest word. It isn't perfect, but it gives a pretty good results. Here are several results. I'm not sure who these people are. Maybe they're experts, maybe they're not. And let's take, for example, the first one. He wrote a paper about application, ICT, and Rubik's. Let's see the second one. Maybe there is maybe the publication out of them. Okay. There was an option for human-computer interaction. It's also, I think, relevant to this case. So. There is a bit of loading. The server is in Israel, so it will take several seconds. Here. So, more several results. Again, I'm not sure if they're an expert or not in the area. Now I will take another example. And found this morning this job description for IBM software engineer. There's some machine learning here in the job description. Machine learning and technology. I think it's the best one here. Again, there is pretty much loading. In several other ones, policy learning with recognizers. I think it's pretty much machine learning. And let's see, the last example should be from a patent somewhere here. And here is a patent paper, use distribution, computing, and resources. Computational resources that are exactly what we need. And here are several more results. We have the number here is the score we calculate. There is an option for, like Google have a +1, so we added also to a user's ability to agree or disagree with our decision in order to improve ourselves. And I think it's enough for enough examples. You can okay. You can see our system our link here. It's pretty long one, and more researchers, and the researchers that I mentioned before or other ones in this area in this site. And if somebody have questions, I will be happy to answer them.